Hello, Algebra 1. We are here to discuss Lesson 8-2, and we are going to be talking about using the distributive property, but we're going to be using the distributive property backwards from what we were doing in Chapter 7. So let me just jump into a couple of things. First of all, one of the ways that we can talk about what we're doing today is actually called factoring. Factoring is going to be any time we take a factor out of one term and figure out what we have left over. So for example, if I look at example 1, letter B, in my book, it says I have negative 4a squared b minus 8ab squared plus 2ab. And in order to factor this, I want to find the greatest common factor, that is the largest number, the greatest number that is common, which means common means it's going to occur in all of my terms. So the greatest common factor, the greatest number that multiplies into every single one of these. So the greatest common factor here, if I look at just the integers in front, just the coefficients, the greatest common factor is going to be 2 for the coefficients. And if I look at the variables, it looks like I have 2 a's here and 1 here and 1 there. So I've got 1a common to all three terms. And I have a b, 2 b's here and a b there, so I have a common b to all of them. So this is my greatest common factor, and I'm going to factor it out, factor that greatest common factor out of all of these terms to see what I have left over. So if I take a factor of 2ab out of a 4a squared b, or negative 4a squared b, I'm going to get a negative 2a. And I can check my work right away by just making sure that I get this back again if I multiply this times this. So 2 times negative 2 is negative 4. A times A is A squared. And B times whatever is just going to be B, because there isn't a B over here. So when I factor out my greatest common factor from this term, I'm left with a negative 2A. Now I'm going to do the same thing for the middle term. Again, negative 8 divided by 2 is going to leave me with a negative 4. A divided by A is just going to be 1, so there's no A term here. And B squared divided by B is going to be a B. Are y'all with me? And finally, on this last one, I have a plus 2AB, and I'm going to be dividing that by 2AB. So 2AB divided by 2AB is going to be just a plus 1. And that is how I use the greatest common factor to factor out the greatest common factor from a set of terms. Okay. There's a lot of different ways that you can talk about it, and I've been using a lot of different vocabulary and probably a few different ways of discussing it all the way through, but that's just kind of the way we do things. You go ahead and try 1B, and I'm going to do that right below here. And so you can go ahead and pause it, try 1B on page 476, and we'll see if you get the same answer I get. My answer is going to start by copying down the problem. 7u squared t squared plus 21 ut squared minus ut. Looking for my greatest common factor, I have a 7, which goes into 21, so I could possibly have a GCF with a 7 on it, but I have no number here. So my greatest common factor as far as the numbers or the coefficients is just going to be 1. And I also have u squared, u, and u, so I do have a GCF of u, and if I look carefully, there is a common t in all three terms. So my GCF is ut, and when I take a ut out of here, I have 7ut plus 21t minus 1. And again, I have to check this to see if I get the same thing back. Now, I don't have to put my checking work back in my notes or on my assignment to show that I've done it, but it's always a good idea just to run through it really quickly and make sure that you get the same thing. So if I use the distributive property the way we usually do it, instead of pulling something out like I did here. But if I use the distributive property to multiply this through here, here, and here, then I should get my original problem back. So ut times 7ut would be 7u squared t squared, because u times u is u squared, t times t is t squared. Ut times 21t should give me 21 ut squared, right? And ut times a negative 1 would give me negative ut. So I checked my work and I did my factoring correctly. I hope you did it too. There's another concept where we're going to call something factor by grouping. And you're going to hear me use this a couple of times as we move throughout the rest of the year. Factor by grouping. And that usually is going to happen when I have 4 different terms. So something like the problem, example 2 in your book. 4QR plus 8R plus 3Q plus 6. All right? So if that is our problem and we're told to factor this as much as we possibly can, I'm going to look through there and I'm going to see, well, my GCF, I've got a Q and a Q, but I've got an R and an R, but no R's over here. 3 doesn't go into, and it just goes into these last 2. So I'm going to factor these differently. I'm going to say I have something in common here, and I have something in common here. Okay, so if I factor by grouping, the thing that I have common in the first 2 terms is going to be a 4R. So 4R is my GCF for just the first 2 terms. When I divide out a 4R, I get a Q plus 2. And again, just to do my quick check, 4R times Q is 4QR, and 4R times 2 is 8R. So I did that right. I haven't actually done any actual steps. I'm just factoring out the common term so that I can look at the problem another way. I might be able to get different information out of it if I do it this way. So now I finished the first 2 terms. Let me look at the second 2 terms. Common between 3Q and 6 is going to be 3. So I'm going to put a plus 3. And when I factor that out, I'm going to have a Q here and 2 here. So 3Q plus 2. 3 times Q would give me 3Q, and 3 times 2 would give me 6. So 3Q plus 6 is what I get when I multiply here. Okay. Now the interesting thing about this particular way of factoring, when I'm factoring by grouping, I made 2 groups and I factored, is that often after I do that first step, I will find that I have another common factor. Both of these terms have a Q plus 2 that's in it. Now you can think of that Q plus 2, since it's in parentheses, you can think of that as a term all by itself. Okay? That whole thing has to stick together. And it's just like if, for example, I had 4RX plus 3X, and I was wanting to factor out something common between that, I would factor out the X, and what would be left? 4R plus 3. Right? So that's how I would factor it out if I had an X term. But now on this one, instead of having an X, I have Q plus 2 as one whole circled thing that has to stick together. So now I'm going to factor out that common Q plus 2 and keep it in those parentheses. And I'm going to see, what do I have left? I have 4R plus 3. How did that go? Does that make a little more sense? Now I can check my work again by multiplying these back out and see if I get what I started with at the beginning of this problem. So if I multiply these 2 sets of parentheses times each other, what do I have to do? I sure hope you said FOIL. So Q times 4RQ would be Q times 4R would be 4RQ. And my outer terms would be 3q. My inner terms would be 8r. And my last terms would be a plus 6. And if we look at what we have here, they might be in a different order, but I have exactly the same thing that I started with. So this factored form and this polynomial are exactly the same. Let's try another one. I want you to do letter 2b from your text on page 477. 2b. Pause the video, and I will do it as soon as you come back after you've made your attempt. So we have 3np plus 15p minus 4n minus 20. Again, I don't have anything common through all 4 of my terms, so I'm going to separate it into 2 groups, like this and like this. In my first group, the common thing is going to be 3p. So I write down my GCF, 3p, and I'm left with n plus 5. Really quick multiplying through again will give me 3pn plus 15p, because 3p times 5 would be 15p. Good enough. Now we look at the second 2 terms. We have a negative 4n minus 20. So we can look and see what's common. And you could say, well, what's common is 4. Or you could say what's common is a negative 4. And in this case, because they're both negative and I kind of like to keep things kind of positive, I'm going to take out a negative 4 because that makes both of my terms here positive. So that's going to be n plus 5. So if I divide this by negative 4, I'm left with n. If I divide this by a negative 4, I'm left with a positive 5. Okay. And again, we see that we have a common n plus 5 and n plus 5 in each of my 2 big terms. So I can factor out that n plus 5 because that's showing up in both of them. Remember that stuff in parentheses has to stay in parentheses. So I put it in parentheses again. Then I open up another set of parentheses and I write down what I have left over. So when I factor out the n plus 5 from this term, I'm left with 3p. And when I factor out the n plus 5 from this term, I'm left with a negative 4. So you should get an answer of n plus 5 times 3p minus 4. I sure hope you got that. Let's try another example. I'm on example 3 in your textbook. We are going to do 2mk minus 12m plus 42 minus 7k. Okay. Again, there does not look like there is anything common. I see a 2 that goes in here. Oh, I could put a 2 in there. And I could take a 2 out of here evenly, but I can't take a 2 out of that 7. And I've got m's here, but not there. So I'm just going to do my grouping thing, and I'm just going to always group the first 2 and the last 2 and just see what happens. If I look at the first 2, there's a 2m, and I'm left with k minus 6. And if I look at these 2, I could take out 7. So I could go plus 7, and I'm left with 6 minus k. Right? Are we all good so far? Now that's not the same as that, is it? But it does kind of look the same, similar in a way. We've got a k, well, that's a negative k, but it's a k, and a 6, and that's, well, let's see if we can do anything else. Let's write it another way. We've got 2m times k minus 6 plus 7 times, I'm just going to write that in the order that we have over here. Okay, so we can see, it is very similar to this, but both of the signs are changed. So here's the trick, what you can do on some of these things. You've got a 2m times a k minus 6, and I can also factor out a negative sign. And if I factor out a negative sign from both of those, what I'll be left with, this divided by a negative is going to be a positive, and this divided by a negative is going to make that a negative. And now we have something common again. So here we've got k minus 6 and k minus 6. Remember that whole thing in parentheses has to stick together. And when I factor out the parentheses from this first term, I'm left with 2m. And when I factor out the parentheses from this second term, I'm left with negative 7. And that's how you can factor that. And I am going to leave it to you to take this whole thing right here, and guess what you should do? FOIL it to make sure that you get that back. And if you did all your math correctly, then this will give you exactly that. How about that? Any questions so far? I hope not, because I'm not going to be able to hear them right now. One other concept here, and this is another really, really good idea that is going to be very important to you throughout all the rest of the math classes you take. I want you to think about something. In math, we call it the zero product property. The zero product property. What does zero mean? Zero is, well, zero. It means that there's nothing there. Okay, well, fine. What's product? Product is the answer when you multiply two things together, right? So if I have a zero product property, what I'm actually saying is I have two numbers. What should I call them? Two numbers. Let's call them A and B. A times B. And I know I'm going to be multiplying them together. It is the product after all. And when I multiply these two numbers together, I get an answer of 0. Now let's think about this a minute. When I multiply two numbers together and get an answer of 0, how can I do that? Well, I could say that one of the numbers is 0, right? Because if A is 0, then that would make A times B 0, right? Or I could say that B is 0, and that would make A times B equals 0 too. Is there any other way I can get 0 as an answer when I am multiplying? No, not that I can think of. The only way I can get 0 to be the answer is if one of the numbers that I'm multiplying is already 0, or both of them. Maybe both of them are 0. Let's think about why this is important for a minute. I could say something that was A or B is 0. That's easy enough to think about. But maybe I have something that's more like, oh, let's say I know 2D plus 6 times 3D minus 15 is equal to 0. Right? Okay, fine. What does that mean? Who cares? Well, I could say that this whole thing, 2D plus 6, is just any number, like A. Right? Or I could say that 3D minus 15, because this whole thing in parentheses has to be treated like one number, right? It's just like I'm circling it and I'm talking about just that little bit. This is just going to be a number. 3D minus 15 has to be a number. And I'm multiplying this number times that number. And I'm getting an answer of 0. So that means either this number or that number has to be 0. So how can I say that? I can say, well, either 2D plus 6 equals 0, or I could say 3D minus 15 equals 0. Well, this is just an equation with one variable. I know I can say 2D equals negative 6, and I could say D equals negative 6 over 2, which is negative 3, right? Or I could say 3D equals 15 and D equals 5. Well, what does that mean? If I put this negative 3 in up here for D, if I substitute that negative 3 in, I get 2 times negative 3, which will be negative 6. Negative 6 plus 6 times well, whatever, we said D was going to be a -3, so I'm going to make that a -3. So I have 3D minus 15. And let's make that a bracket. Well, here I've got this whole thing is 0. And now this thing is still going to be -9 minus 15 equals 0. Well, it doesn't matter what this is because I'm multiplying this number by 0. So I have to get the whole answer of 0, which is what I wanted. And if you do the substitution using a substitution, not substitution, it's late, excuse me. If you do the same substitution using D equals 5 and put a 5 in for D here and here, you'll find that this term goes to 0. And if I multiply 0 times anything over here, my answer will still be 0. So this is the zero product property, and it helps us to find solutions to problems where we can factor things out. And that's one of the reasons we factor things out, so that we can find solutions that wouldn't be as obvious if we didn't factor them. So let's do another example. Let's say I'm going to work on 4A on page 478, and I want you to pause the video and see if you can do the same thing. We have 3n times n plus 2 equals 0. So I have two numbers. One of my numbers is 3n, and that has to equal 0. Another one of my numbers would be n plus 2. So I could have 3n equals 0, or I could have n plus 2 equals 0. Here, if I solve for n, I divide by 3. 0 divided by 3 is 0. So n equals 0. Or, if I subtract 2, n equals -2. I have two possible answers. This whole thing will be 0 if n is equal to 0, or if n is equal to a -2. -2 plus 2 will give you a 0, and 0 times no matter what anything this would be has to be 0. So two answers for this kind of problem. Pretty interesting. Two answers. Can you imagine having one problem with two answers? Let's do another one, 4b. Again, you stop the video and try to do it on your own. 8b squared minus 40b equals 0. Let's factor out whatever we think is common here. I am seeing 8b be common, and I have b minus 5, and I think that's all I have to do. So 8b squared and minus 40b would be there. I factored it correctly. Now again, remember, my zero product property tells me that 8b equals 0, or b minus 5 equals 0. If I divide by 8, b equals 0, b equals 5, because I could just add 5 to both sides. So I have two answers, b equals 0 and b equals 5. One more example. You guessed it, we're going to try 4c just to see if you understand this zero product property. 4c says, pause the video so you can try it on your own, x squared equals -10x. So for this one, we're going to want to get all the x's together on one side of the equation. So I'm going to say x squared plus 10x equals 0. Okay, I need to get the x's together, and the zero product property only works if it is equal to 0. So now I'm going to factor out x, have x plus 10 equals 0, x equals 0, or x plus 10 equals 0, and x equals -10. So two answers, and there we go. That is how you factor by grouping, and this is how you use the zero product property. And I promise you will come to love the zero product property as we move on through the rest of math. All right? Enjoy your homework. I'll see you in class.